Good day. Today we will be sharing our insights regarding our study entitled Hydraulically Operated Automatic Aircraft Wheel Chocks, a proposed alternative design to the manual wheel chocks in the airport apron. For the background of the study,
To start off, according to an article entitled Chocks Away in the World War II Period, the wood type is the usual chocks used by the British in the earlier period. Those chocks may get the aircraft landing gear to immobilize, but it can crack, splinter, and rot that affects its structural integrity, which can result in foreign object damage to aircraft and injury to personnel. Plus, it is more costly. Why? The maintenance for wood chocks is painting, used to remove splinters and small holes. So why would we use an equipment that can provide us services for the short term? Another, it is one of the reasons for a delayed flight. Here is an example. The purpose of the study is to improve the common way of chocking. So we have come up with a design that includes hydraulics, solid steel bars, and heavy-duty rubber wheel chocks. Together, this can form a convenient and more efficient way of chocking that ensures the safety of the ground personnel together with the passengers and crews. For the introduction,
wheels have become one of the greatest inventions in our everyday life, from transportation, modern-day machineries, and everything in between. However, given its shape, keeping it stable and stationary is a dilemma even before. And with this, the emergence of chocking came into light. Aviation is a fast-paced industry where continuous developments and innovations are the norm. Because safety is the highest priority in our industry, changes and developments are necessary. Even the smallest of equipments, especially the wheel chocks, which are manually inserted by ground personnel, must be given utmost considerations. With this, the researchers came up with the idea of designing a hydraulically operated automatic aircraft wheel chocks with the aim of lessening and eventually eliminating the risks and problems associated with manual chocking. For the statement of the problem,
The researchers are proposing an automatic aircraft wheel chock design with the help of the four following questions, which are: first, what is the proposed design, which will tackle the basic configuration of the design? Second, what are the materials used in the proposed design? This question will identify the whole technicality of the design. The third question, how do the above mentioned specifications of automatic aircraft wheel chocks compared with the commercially available aircraft manual wheel chocks? In this section, the two said variables will put to the test in terms of operation. Lastly, how effective is the proposed design as perceived by instructors and students? In this category, it will showcase the insights and suggestions of the respondents. For the next part, which is the related literature,
throughout all the innovations from the past century, a relatively small device, yet a crucial aircraft part, has remained constant. In the past, they were often made of wood with rubber-coated bottom for enhanced grip to the ground. Today, they are usually made from rubber, which are durable and with ribbed specification. However, we cannot still exclude the fact that its utilization poses great risks to the ground personnel and the workplace in general. Every year, Airbus receives numerous reports regarding the issues with parking procedures at the end of flights due to improper application of the procedures. And a factor that suggests to improve this problem is the proper chocking procedure. Particularly, the Aircraft Maintenance Manual Maintenance Procedure 10-11-00 parking procedures includes instructions for installing the wheel chocks. For the research gap,
for the research gap, through observations and data gathering procedures, researchers ascertained that the chocks are one of the equipment in aircraft operation which lacks innovation, resulting to accidents and flight delays in the aircraft operation. So researchers had an idea to develop and upgrade our existing chocks. For the next part, which is the research paradigm conceptual framework,
for the conceptual framework, it is divided into three parts: the input, process, and output. Here are the raw materials for the product. For the process of the hydraulics, we need to connect the long threaded rod to the 12 volts DC motor via silicone tube. Next is attach the hollow tube to the nut via solid and hard adhesives. Then insert the PVC tube and attach it to the DC motor via solid and hard adhesive. Next is solder the negative and positive end of the single conductor wire to the DC motor, and then attach to the other end of both wires to the DP-DT switch, and attach the portable transformer adapter to the DP-DT switch. For the assembly, secure the 3D printed fork joint to the hollow tube by using the epoxy steel. Next is all 5 3D printed rods must have fork joints attached to them. Next is drill the middle rod and fasten a sheet metal on top and bottom to stabilize it. Lastly, insert the wheel chocks on the L-shaped rods and insert the lock pins on the wheel chocks end. For the rubber wheel chocks, we use the 3D printed aircraft wheel chocks attached with felt paper with colors of yellow and black. For the stabilization, we used plywood as the base for the pavement, put the sheet metal on the plywood and fasten it, and then place the hydraulics above the sheet metal. And for our output, we would come up with the hydraulically operated automatic aircraft wheel chocks. For our research methodology,
researchers use an experimental design to create an arrangement of improvement to existing chocks. Comparing the said design, which is the hydraulically automatic aircraft wheel chocks, to the existing manual wheel chock is the main idea of the experimental. The two said variables will undergo appraisal in the field of operation. For the first statement of the problem,
What is the proposed design? The researchers aim to introduce a wheel chock design which is hydraulically operated and integrates the existing rubber wheel chocks to a slider crank mechanism that will allow the chocking procedure to take place without manual insertion or manually placing the chocks. In the future, the researchers aim to develop the mechanism more as well as the overall structure of the automatic wheel chocks. For the second statement of the problem,
for the second one, what are the materials used in the proposed design? We've collected the materials for the miniature representation of the hydraulically operated automatic aircraft wheel chocks and divided them into 3 different categories, namely the foundation. This includes the sheet metal, which corresponds to the steel base plate. Second, the major assembly. It includes the electric actuator, 3D print of solid steel bars and chocks. Lastly, the accessories, which includes the 3D print of the fork joints and anchor bolts to stabilize the entire assembly. For the conclusion, the materials are high in quality for the component to perform their role and support the proposed design's objective, the avoidance of close contact. For the recommendation, since the researchers already utilized the electrical switches to operate the hydraulically operated automatic aircraft wheel chocks, the application of sensors would improve the objective of the study, which is the remote operation of the product. And for the third one,
Third statement of the problem, how do the above-mentioned specifications of automatic aircraft wheel chocks compared with the commercially available aircraft manual wheel chocks? The findings, the proposed design show the great advantage in terms of material composition, product capability, and lastly, force output. Researchers concluded that the proposed design surpassed the commercially available chocks in terms of material composition, product capability, and lastly, force output. Researchers also received a recommendation to make the product more automatically by installing sensors on it for smoother and accurate operation in the field. And lastly, for the fourth statement of the problem,
how effective is the proposed design as perceived by instructors and students? The study discerned the design's effectivity through the eyes of instructors and students of Philippine State College of Aeronautics, Fernando Air Base Campus. The design has been regarded as feasible by the majority. However, the researchers still plan to extend the study outside the school grounds by consulting the professionals who specializes in the fields of engineering and design. This way, it will pave way for the designs and the insights to be more advanced and eventually achieve the improvement for a much more efficient and better design. And here's a video clip of our design.
here are our references for our study. Thank you and have a good day.